This is the Permutations and Combinations tutorial. Question 1. How many ways can the letters of the word excellence be arranged if there are no restrictions? Well, firstly, imagine that, let's count what we have. We've got 10 letters in the word excellence. Of those 10 letters, there are 4 E's, there are 2 C's, there are 2 L's, and there is 1 X and 1 N. So 1 X and 1 N. How many ways are there to arrange this word? Well, if all of our E's were distinct, if we could tell them apart, and if all of our C's were distinct, and if all of our L's were distinct, then the number of ways in which we could arrange 10 distinct items would be 10 factorial. However, the items aren't distinct. We can't tell the E's apart, or the L's apart, or the C's apart. So we have to divide through by the number of arrangements that are effectively repeated because the items look the same. So that is, we divide through by 4 factorial because there are 4 E's, 2 factorial because there are 2 C's, and 2 factorial because there are 2 L's. This gives us a final answer of 37,800. What about if we want to find the number of ways of doing it if the 4 E's are not all together? Well, what we're going to do to calculate this, it's very hard to work out directly how to do it if the 4 E's are not all together. Instead, we'll do the total number of arrangements minus arrangements with the 4 E's together. So, how many ways can we have the 4 E's together? This time, imagine we've got the word excellence again, but we know our 4 E's have to be together. So let's block those 4 E's together and treat them like one super element. So this is roughly the same as trying to arrange the word super E X C L L N C, right? All of our E's are now together in this one super E, and we have 1, 2, 3, 4, 5, 6, 7 letters now to arrange. How many ways can we do that? Well, if there were 7 distinct letters or items to arrange, we would do it in 7 factorial ways. However, because I now have 2 C's repeated and 2 L's repeated, I need to divide through by 2 factorial for the C's, 2 factorial for the E's. And this gives us 1,260. So going back to the original question, the arrangements without 4 E's together will be 37,800 from the first part, minus 1,260 from what we just worked out before, to give us 36,540. The last part asks us the number of arrangements possible if it begins with the letter E and ends with the letter L. Well, again, this is easy enough to do. It means I start with the letter E, that's fine. Then I've got 8 spaces, and I end with the letter L. Now, in these 8 spaces, what do I have? Well, I've got 3 E's, 2 C's, 1 L, 1 X, and 1 N. So again, how many ways are there to... This E and this L are fixed. In here, I now have 8 letters to arrange, which I could do in 8 factorial ways if they were all distinct. But I've got 3 E's repeated and 2 C's repeated, so I divide by 3 factorial, 2 factorial. And that gives me an answer of 3,360.